Welcome back to DarkScript, and today we'll talk about cooling units and their high importance in maintaining the health of your computer components. Here's a brief overview about the purpose of having cooling mechanisms inside your computer. Every computer requires a solution that will dissipate and moderate the heat that is being produced and accumulated by different components on the motherboard, such as the processor, the hard drives, the graphics cards, power supplies, and even the motherboard as an individual component. For this purpose, different cooling units can be manually installed inside the computer or embedded within the generic hardware. The main heat generators in a computer are usually the processor and the graphics cards, and not surprisingly, they are both equipped by default with their own dedicated cooling technologies, such as thermal paste and fans. To display the temperature of each component, you can run SPECI or CPU-Z as shown in previous examples in this course. Cooling units are extremely important to the general system health, as having them increases the lifespan of the internal components, prevents hardware failures, protects the data on the hard drives, and improves the system's performance. Several factors may increase the heat or impact the cooling processes in a computer, such as the accumulation of dust, poor heat transfer, and bad airflow. To prevent them, always check the room temperature and the general air circulation. Equip your computer case with a decent system fan. Casually clean your computer from the inside and frequently monitor the components' temperatures. Temperature control, cooling units, and fan RPM can all be managed from the BIOS or the EFI, which will be discussed in a later module. In this session, we will be discussing different cooling mechanisms for internal components. The first one is air cooling, which is also known as system fans. Computer fans are internal devices, either built in or manually installed, which are responsible for the active cooling of internal components inside the computer. Fans are needed near components that produce a significant amount of heat, such as the processor, the hard drives, the power supplies, graphics cards, and the chipset. These components must be kept within a specified temperature range in order to prevent overheating failures, instability, malfunction, and physical damage. Per best practice, it is also recommended to install a fan on the case itself, which will draw cool air through either the front or the bottom of the case. Choosing the right fan to install on your system typically involves the following considerations: the device brand or OEM, the noise in decibels, RPM, which stands for repetition per minute, power consumption, dimensions, and connector type. To monitor the health and the usage of your system fans, you can download the freeware Open Hardware Monitor or SpeedFan. Let's do a quick demo of the Open Hardware Monitor tool. So I'm quickly going to open the hardware monitor just to show you briefly what type of output you can expect from it. So this is the hardware monitor. As you can see, this program is very simplified. It shows you the name of your computer at the top of the hierarchy right here, and then it shows you the model of your motherboard. And below, if you scroll down, you can see the state of different components, including your system fans, the processor, memory, storage, and much more. So this application can generally show you your hardware condition, and I chose to use it simply because it shows the status and RPM of your fans. So right here you can see that my maximum RPM is about 1800 RPM or 1800 repetition per minute. And the actual value right here is almost 1700 RPM. That's the speed of my fan at the moment. Next, let's talk about liquid cooling. Liquid cooling, or water cooling, is a more modern technological approach for CPU cooling, which has quite a few advantages over air cooling, such as the water's higher specific heat capacity and thermal conductivity. Compared to fans, liquid cooling is more power efficient and produces less noise. It is more ideal for overclocked hardware, which reduces the risk of overheat, and has some visual and aesthetic pros as well, making the computer look like a piece of art from the future. Due to the increasing heat density in computer systems, liquid cooling units are becoming more and more common. However, they have a relatively complicated design and are more difficult to set up and maintain. Despite their efficiency, They're more costly and are considered more susceptible to leakage than fans, making them less reliable and less safe. Due to their design, liquid cooling units require larger computer cases and weight more than typical fans. You should also be aware that liquid cooling is not supported for all CPU types. For those of you who still wonder how the liquid cooling mechanism actually works, have a look on the right. The general idea is that water in room temperature will be stored in a reservoir and then processed by either a radiator or fans so it becomes colder and then cools the processor. Once the water starts heating again, it goes back to the reservoir and starts the same process again. The next one is called thermal paste. It is also known as thermal grease and thermal gel. Thermal paste is a semi-liquid that should be applied on the front-facing side of a computer's processor. This compound is used to allow efficient heat transfers from the processor to the cooling unit, which is set up on top of it. Properly applied thermal paste is an important part of a cooling system, and going without it is not recommended for your CPU. However, this does not mean that it will necessarily burn out and fail without it, although the chance for it to happen might increase. Without thermal paste, the processor's temperature will consequently be higher, leading to slower performance or thermal throttling in order to prevent overheating. Basic thermal paste usually contains silicon and zinc oxide, while more expensive pastes contain heat conductors such as silver or ceramic. Now let's list a few more popular cooling mechanisms. The first one is a heatsink. A heatsink is a metallic device with a large surface and high thermal conductivity, which is passively used on top of other components to efficiently dissolve and redirect their heat elsewhere, similar to an air cooling unit. Heat pipes are hollow tubes containing a heat transfer liquid that absorbs the heat on one end of the pipe and evaporates it on the other hand. Many computers use heat pipes in addition to existing fan-based cooling units to keep a safe operating temperature for all components. And last we have the software-based cooling. Apart from hardware-based units, cooling can also be achieved by using software or firmware to set the hardware functionalities differently, such as undervolting, which is the practice of running the processor or any other component with voltages below their original manufacturing specifications, thus making them draw less power and produce less heat, or soft cooling, which is the practice of using software or firmware to take advantage of CPU power-saving technologies and thus minimize the power consumption of the element. This can be achieved from the BIOS or Tech Power Up freeware, as you can see on the right. That's all for today. Thank you for watching again, and I hope to see you in the next video.